in general, we see two primary failures depending on the results of your energy audit. Typically, if you're going to weatherize your home, air seal and insulate it, the idea is you're going to tighten it down dramatically. So controlling the sources of moisture becomes much more important. The two sources of moisture that predominate in our climate zone come from the crawl space or from indoor moisture loads such as your bathrooms and showering activities or cooking activities, specifically when you're boiling water. A crawl space that is bone dry can introduce up to 12 cups of water per 100 square feet of dry area. So if you got a 400 or 500 square foot crawl space that's still bone dry, you've got up to a gallon of water per day coming out of the ground and introducing itself as moisture underneath your home. So typically you want to have a vapor barrier and some sort of solution to control the moisture in the crawl space area. So why don't we go crawl in here and see what we've been doing all morning.
Oh.
Now we're actually in the crawl space, and we go over step by step how to properly insulate and air seal your crawl space in addition to controlling moisture. The first thing you want to do in your crawl space is make sure that the air that's in here is not interchanging or interfacing with the air inside your house. So all these little plumbing penetrations and electrical lines and cable TV wires and whatever is in the crawl space and where they've drilled a hole through the floor upstairs, you want to move some of this insulation to the side and spray foam around all those little penetrations. That will physically stop air movement that's in the crawl space from gaining access to the house. That's step number one. Step number two is to control the moisture down here. You want to run enough excess material up the sides of the foundation walls so that you can then seal the plastic physically to the concrete block or foundation. We're going to put a couple strips down here of liquid mastic. And what that's going to allow us to do is to physically seal this plastic to the concrete block. Once the concrete block has been sealed, you take your rigid board insulation and you quite literally install that right on top of that plastic that's been installed right there. And once that's in place, you're going to want to foam seal around the edges of the banner rim joists and secure your foam board in place with construction adhesive and nails or screws as necessary. Alright, so now we're on the finished side of the crawl space. We've already got through the first three steps where the vapor barrier is now neatly pulled to the edges of the foundation wall. It's been sealed underneath to the concrete itself, underneath this 2-inch thick rigid foam board. The rigid foam has been installed on top of that, and we've used spray foam to seal the banner rim joist area so that now there's no air leakage from the outside coming into the crawl space. The vapor barrier is down and well sealed, so there's no water vapor coming up from the ground into the crawl space. And we've also sealed, and we've moved all these little pieces of insulation out of the way to seal any of the ceiling penetrations that were allowing air to move from the crawl space inside. With overly tight building shells, or if we're recommending to you to over tighten your house, but then to provide back mechanical ventilation, bathroom fans and the source control of moisture are two of the most important things for you to focus on. A very easy way to do that is to make sure that the bathroom fans are being run all the time or when they need to be run. There's a couple of different strategies in order to do this. The one that I think is the cheapest and the easiest to retrofit is to put a $15 to $20 timer / motion sensor control on your bathroom fan switches, so that every time this fan is left in auto, you walk by this motion sensor switch, the fan itself comes on, it stays on for 20 minutes, and you've left that room and you don't have to ever worry about turning your bathroom fan off or on again. Now, in this room also we ran into a couple of other issues with ventilation in the sense that we did not even have a bathroom fan installed. So what we've done in retrofit is to actually install one into the skylight shaft. And there's a design issue here that made this a little bit trickier of a job, mainly because they installed initially a skylight shaft directly above the shower stall. And the shower itself is creating a warm, humid, moist air, which is less dense than cold air, and it's rising up into the skylight shaft. And that warm, humid air over time will do one of two things. One, it'll decay building materials, so it'll decay framing and drywall, but more importantly, it will drive paint failures. And you can see up in the skylight shaft, we've got peeling paint on both sides. So what we've done, instead of moving the skylight shaft, which is expensive, is to install a bathroom fan in one of the side walls of the skylight shaft itself, which is now controlled from our motion sensor switch. This is going to, every time they use the shower or even enter into the bathroom, turn this fan on, which will remove moisture and any other air, stale air that's inside the bathroom.